Okay, hi everybody. So today we're going to start on 76, and we're going to do 76 through 81 of the multiple choice out of the Canary packet. Okay, so let's just jump right into it. Okay, so we have the graph of f prime, the derivative of the function f is shown above. Okay, so this is the derivative here. The domain of f is the open interval from 0 to d. Which of the following statements is true? Okay, so f has a local minimum at x is equal to c. Okay, so this is the derivative. The derivative is going from positive to negative there. That means that this is a local max. Okay, furthermore, so we just get into this while we're here. The derivative here goes from a negative to a positive. That means there's a local min value there. Okay, so A, f has a local minimum at c. That is false. Okay. B, f has a local maximum at x equal to b. Okay. What I know is that the derivative is a positive value. They're trying to bait you into thinking that this is f of x. Okay, and it's not. So it's not going to be that. C, the graph of s has a point of inflection at a f of a. Okay, so the point of inflection, a lot of times how we locate that is you take the second derivative of x and you set it equal to 0. Okay, so up here, the only place where the second derivative is equal to 0 is right up there. And it does go from a positive to a positive second derivative to a negative derivative. So there is a point of inflection at b, but not at a. Okay, so that's not true. So I didn't think this is supposed to be here. I'll have to cross that off. Okay, so the graph of f has a point of inflection at b, f of b. We just talked about that. That is true. Okay, you plug in the value b, you're going to get out b prime. So this looks like it's true. Let's just go through e to make sure. The graph of f is concave up on the interval from c to d. So c to d is down there. Concavity is determined by the second derivative, and the slope of the tangent line there is negative. So this is false. So the answer there is D. Okay. Number 77. Water is pumped out of a lake at the rate. And by the way, this is the calculator version. That's why you see the graphing calculator up here, which we will use in a little bit. Okay. Let me move it. Well, I'll just leave it alone. Okay, so water is pumped out of a lake at the rate of R of t is equal to this cubic meters per minute. Okay, so that's the rate at which it's pumped out. So that's dV dt. Okay, the rate at which the volume is pumped out. Where t is measured in minutes, how much water is pumped from time 0 to 5. So we know if we want to calculate the total amount out of there, what you have to do is you have to integrate the rate. So all we need to do is we just need to integrate from 0 to 5 of r of t dt. Okay, so we go to our graphing calculator and we go ahead and we go to y is equal to. Let me clear off the other information that is already on there. Okay, and then we're going to enter in the equation. So I have 12 times the square root, and then remember fraction. Fraction is second alpha. So it brings up the, wait, where's it at? Why am I not seeing it? Second, oh, sorry, not second alpha, second alpha F1. My bad. Okay. So n over d feels like a long time since I've done this. And then I have x all over x plus 1. Okay. And then I get out of there. So the equation is now in there. So I'm going to go back to the main screen now. Just clear out everything that I have. I'm going to do the integral. So I'm going to go math, and all the way down is 9. We're going to integrate from 0 to 5 of that function. Now we've had that function entered in there, and it's in the y is equal to page. So you know you can access the variables there by going alpha, f4, f4, right? Yeah. And there is y1. And then I just go with respect to x. Okay. And that should give us the correct answer of that is curious. Why is it taking so long? There we go. So 47.193. So the answer there is D. Okay. Not sure why that took so long. Usually it goes faster than that. Okay, next page. 78. The graph of the function f is shown above. For which of the following values of c does the limit as x goes to c of f of x equal to 1? Okay, so this is f of x, and I want to know what the limit is as we go to c. Now, I don't know what c is, but I do know the limit's going to be 1. So where is 1 at? 1 is the line right here. So I have 3 different possibilities here, right? I have x is equal to -2, I have x is equal to 0, and I have x is equal to 3, because those are the 3 places where it crosses that line. Y is equal to 1. Now, remember, in order for a limit to exist, it has to approach it from both directions, not just one direction. So if you go to -2, you can see as you approach it from the right or the positive side, it's going to 1. As you approach it from the negative side or from the left, it's also going to 1. So 2 works. Okay, so check. Okay, 0, you can see that also works. But at 3, you can see it fails, because as you approach it from the left or the negative side, it's going to 1. But as you approach it from the right-hand side, it's actually going to something else, say a half. Okay, so that one does not work. So we only have -2 and 0 only. Okay, number 79. Let f be a positive, continuous, decreasing function such that a of n is equal to f of n. If you have the summation from 1 to infinity of a of n and it converges to k, which of the following must also be true? Okay, so let's take a look at what these are. Okay, so you have the limit of as n goes to infinity of a of n is equal to k. Now I have the whole entire series going to k, but you don't have a of n going to k, right? So the series is adding up a whole bunch of terms along the way, where the individual term a of n is just a single value. So what this is basically saying is the very last term there, and I know there's not a last term because you're going to infinity, but the last term as you go to infinity is going to go to k, and that's simply not going to necessarily be true. Okay, so you don't know that that's true. Okay. Okay, the integral from 1 to n of f of x dx is equal to k. So they're basically correlating these two together and saying they're the same thing. No, that's not the case. Okay, just because this goes to k doesn't mean that this one's going to go to k. Okay, the integral from 1 to infinity of f of x dx diverges. If this converges, does that automatically mean that the integral converges? Okay, we'll come back to that. Okay, same thing here. Do I automatically know that that diverges? And then here, so by the way here, so this is just going up to n, this is go up to infinity, so these are basically the same two notions. Okay, so what do we know? Okay, so go back and do the integral test. Okay, so what does the integral test tell us? The integral test looks at what the series is, and if I want to know if this converges or diverges, I can basically integrate the same thing and figure out what happens there. Okay, so if I'm looking at a series and this diverges, it turns out it diverges, and I didn't know that, so I'd use the integral test. So I went over here. So this turns out it converges, and I didn't know what it was, so I went over here to figure out what it was, and I used the integral test. And if it ends up converging here, then that means it should converge there. Okay, so the answer there is D. Okay, and then the last two questions. Okay, the graph of the function f is given by, or the derivative of the function f is given by that equation. How many points of inflection does the graph of f have on the open interval from -2 to 2? The easiest way to do this is to graph it. Okay, so I'm going to go to y is equal to, we'll clear off what we have here. And now I'm actually going to enter in the derivative of this function. Now I can do the derivative out by hand and then enter it in, but even easier than that, the graphing calculator does this for me. So all I have to do is go with math 8, which is the derivative, and I'm going to take Actually, you know what? To even make it a step easier, let's go ahead and do this. So the first function I'm going to enter in is I'm going to go ahead and enter in x squared times cosine of x squared. We'll close it. Okay, and now what I'll do is I'll come down below here, and I'm going to go ahead and take the derivative of this. So I just realized I don't have my glasses on. I was like, why am I seeing so hard? Why is it so hard for me to see? So anyway, so I'll go back here, and I'm going to go math 8, and I'm going to take the derivative of this function. So I'm going to go d dx of y1, so alpha f4 brings up the variable list, so y1, and then I'm going to take the derivative of this with respect to x. Now, when I graph this, I only want to see y2. I don't want to see y1 because I don't really care about that. I just want to know the second derivative. So I'm going to go up here and turn it off. Okay, and now I'm going to go ahead and graph it. Now, I only want to know on the interval from -2 to 2. So I'm going to change the window, and I'm going to go from -2 to 2. Okay, so now I go ahead and graph it. And there it is. Okay, so what do I want to know? Okay, as this is actually panning out, what do we want to know? We want to know where the second derivative is equal to 0. Sorry, actually, let me restate that. I want to know the points where it switches concavities and the point is defined, okay? So if you take a look here, we need to figure out how many times it switches concavity. Well, down below here, this is where the second derivative is going to be negative, and up above here is where the second derivative is positive. So anytime it crosses that x-axis, it's going to go ahead and go from a concave up to a concave down or vice versa. So all we have to do is count this up. So 1, 2, 3, 4, 5. So the answer there will be, drop my pen. My answer there will be E, or 5. Okay, last one, 81. Let f and g be continuous functions on the interval from a to b. If you have the integral of f of x dx equal to p, the integral from c to b of f of x dx equal to q, and the integral from a to b of g of x dx equal to r. And the integral from a to b of g of x is equal to s. Okay, so what is this going to be equal to? Okay, so we note that we're going from a to b and b to c, a to b and c to b, a to b and c to b. So you do have to be careful there with the negatives, okay? They're trying to get you to switch it around. Okay, so I'm going to go ahead and split this apart into f and g. So this will be the integral from a to c of f of x dx minus the integral from a to c of g of x dx. Okay? Then I need to break it apart. Now, c appears to be between a and b, right? So f of x is a continuous function from there to there. So I'm just going to go ahead and wonder if there's a mistake here. It actually doesn't mention anything about c at all. So we're on 81. Oh yeah, I am missing a piece here. I'll have to go back and enter this in. Okay, it also should state if a is less than c, which is less than b. Okay, so c is between a and b. Okay, so all I'm going to do is I'm going to break this apart, and then I somehow have to access this. Okay, so I'm only going to go from a to c. So let's take a look. What would this look like on a number line? Okay, so you have a, you have b, and you have c. They want to know what the integral is from a, no, actually, sorry, this is c, and this is b. So they only want to know what this portion is. But what did they give us? They give us from A to B, and they also give us C to B. So how can I take this length right here, and get to this length? And let me just, I'll call these, I don't know, L1, L2, and L3, okay, because they're lengths. So what do we know? We know that L1 is equal to L2 plus L3. And what I want to know is I want to know what L2 is. So go ahead and solve for that. So L1 minus L3 is equal to L2. So that's really what I want to know. So what do I need to do? I need to take all of AB and I need to subtract away CB. Okay? So this right here is the integral from A to B of f of x dx minus the integral. Remember we said we're going to take away CB of f of x dx. And then in here, minus, I'm going to put big brackets around this because you can see by the answers, it's all in the sign of each one of these. Okay, so I'm going to be careful here. So this would be the integral from A to B of g of x dx minus the integral, once again, from C to B of g of x dx, like that. Okay, so let's go ahead and place in the values that I know. The integral from A to B, well, that's just P, minus the integral from C to B, well, that's just Q. I don't know. That's not a Q. Been doing too much math lately. Okay. Minus the integral from A to B of g of x. A to B of g of x is S. Minus the integral from C to, did I do that right? C to B. There's another mistake here. This should be from C to B. Okay, boy, I made a lot of mistakes in writing this. Sorry, you guys. Oh, no, that was right. That was right. Here's C to B of g of x, okay? Oh my gosh, I'm all over the place. The integral from A to B is R. Sorry. And then the integral from C to B is S. Okay, I apologize. So P minus Q minus R plus S. So minus plus, minus plus. So the answer there will be B. Okay, sorry about that confusion, you guys. I'm sure you guys are picking up on my mistakes. You guys are always really good at that. So, okay, that's all we got. Until next time, take care.